Thank you, team. Welcome. As Karen stated, this is the education for the A9000 platform, which is the IBM all-flash storage device that's been based off the XIV technology. This is one of 4 sessions that will be held. We are fortunate enough to have Steve Solon for giving the education for us. Steve has been a long-time partner from Systems Group with us, partnering through the XIV acquisition and up through the A9000 now. The A9000 has been woven into our global strategy. So I would encourage everyone to go look at our 1Q posting for our global storage strategy. Our distributed storage strategy up until last year was really primarily based on SVC. We started last year shifting away from just SVC. We introduced our solution called IP Hyperstore, which was the XIV 314 in an iSCSI fabric. Well, in 1Q, we've stepped it up even further. We've added the A9000 into the iSCSI IP Hyperstore solution, and we've also allowed the design to be used for fiber channel solution. So we have basically an all-flash fiber channel, we have an all-flash iSCSI, and we get a combination of the two with A9000 and XIV. SVC is still in our global strategy and will remain so for some time. There's certain capabilities that it's still stronger at, and it's very clearly called out in our global strategy. But I would encourage you to, first and foremost, become an expert in this technology because it's coming. Our future in GTS is going to be heavily flash-based, heavily SDS-based, and iSCSI-based. You've seen some of this happening over the last year. 1Q, we've shifted harder to it, and throughout the year, we're going to continue to push to it. So this is our future. We are encouraging people to have discussions with your DPE and your account teams associated to this new technology and these new capabilities. They're very cost attractive. Essentially, Flash has gotten to a point where it's crossed that mark that we've been waiting for. Flash has been, just really expensive for a very long time. It's not anymore. And as such, it's in our strategy, and I would encourage you to, again, to do all you can to support our strategy and become an expert in this technology. So I appreciate your time today. Do ask questions, and I'm going to turn this over to my friend Steve Solon.
So I'm Steve Solon. I'm one of the corporate solution architects. Like Jim said, I've been working with the XIV line since the time of the acquisition, and have had about 13 years of previous experience with other IBM storage before that. So been around the storage game for quite some time. I just went to the second slide real quick, looking at the kind of the portfolio from way I look at when we talk about our enterprise portfolio. Again, we're going to be focusing on the A9, the A9000. Just one more question, Karen. This is an internal call, right? Just IBMers and contractors?
That's true, yes.
All right, cool. So I will throw roadmap stuff in there as I go along, as I think of it. We might want to, at some point in time, add a session that is just strictly a roadmap session, but we'll deal with that after we deal with the first 4. So again, the 9000 and the 9000R, we'll be talking about that today. I mean, I'm going to talk a little bit about the 900 because it is the foundation on which we built the 9000. And then Jim mentioned SVC, and you see the SVC really is the V9000. That's again the Flash 900 with the SVC nodes in a integrated solution. So when we came up with this storage solution, right, we grabbed a lot of different pieces from a lot of different places, right? You see the Spectrum Accelerate, and that is, okay, so we again, left-hand side, right, we got the data services and Spectrum Accelerate. That is essentially the XIV code, right? We've taken that code, and we now have that same code architecture kind of running in 3 places, right? I've got it running where it started in the XIV. I also have the ability now with Spectrum Accelerate to take that same architecture and run it on a virtual machine on a ESX hypervisor and turn a bunch of ESX servers into essentially into XIV. We call that Spectrum Accelerate. And I've also taken that grid architecture and then modified it a little bit. Now I'm running it on top of the 900. So I have to make the A9000. We took the 900 and the XIV or grid architecture and kind of put them together. We also went out to our research folks and grabbed some help for some of the data optimization stuff, right? The XIV has done compression for a while now. Same sort of compression, the real-time compression that we've been doing in the SVC line for even longer. But to the A9, we went ahead and we added deduplication, and I'll talk more about that in detail later on. And then the GUI team came up with a new GUI, and if there's time, I've actually got it up and running here, and I might walk through the new GUI real quickly if we've got time at the end. So, and this gives customers a lot of choice, right? It gives them the ability to kind of pick where they want to run this grid architecture. Again, I can run a performance optimized on the 9000, which we'll focus on the rest of the time. I've got my capacity optimized solution with the XIV. We are talking about a number of different options to come up with a capacity optimized solution using Flash. So while there may be one more drive qual left for XIV, we may do a 10 terabyte or a 12 terabyte drive for XIV. That's not committed yet. We're talking about it. I will follow up at some point in time with a capacity optimized offering that is based on the Flash, the Flash as well. And then I get, again, the software-defined version where a customer can either run it on-prem or run it in Bluemix, previously known as a soft layer, right? And then just run that software on their own hardware. So you look at the data services there, right? I've got snapshots in all of them. I've got sync and async mirroring in all of them. I have 3-site replication in the XIV. That is a roadmap item for the A9000. Then provisioning, again, very clearly specified in Accelerate and XIV, kind of managed by the system itself in the A9000. In the XIV, if you're familiar with that, that we allow or we force the customer to manage hard capacity versus soft capacity. In the 9000, really, we just create a pool and create volumes in that pool, and the A9000 manages that hard capacity, soft capacity in the background. I have Hyperscale Manager, again, which is the new GUI. I have Hyperscale Mobility, which is the ability to move volumes seamlessly between boxes. Now, I currently have that between Accelerate instances over iSCSI. I have it between Gen 3 over on Fiber Channel, and I currently have it in the A9000, not the 9000R, but I have that in the 9000 right now, again, over Fiber Channel. Jim and I are trying very hard to get the Hyperscale Mobility pulled into the 9000R platform. I hope to get it done with the 12.1 release, which is coming in May. It doesn't look like we're going to get there, so now we're pushing for the 12.2 release, which is the end of the year. We'll continue to push on that. So again, mobility, 9000 only, coming on the 9000R. Consistency is the ability to have a cross-box consistency group. I do support hot encryption on all of these platforms, and that's a benefit because if a customer decides sometime down the line that they need or want to do encryption, this platform allows you to do it hot, basically just enable encryption, and you don't have to, unlike some of our other product lines, you have to evacuate the box, enable encryption, and then refill the box. I can do it hot. You have multi-tenancy in this family as well, so I have the ability to create domains and then assign users to domains, and from that perspective, that user only sees their domain. They don't see anything else. Now, we'll talk about the grid architecture in a little bit. So this is a logical separation, not a physical separation, but it does allow the user to see that to only see a part of the box that the super user essentially assigns to them. I have quality of service for host, domain, pool, and volume. That is true for the 9000R. I do not have volume level quality of service on the XIV yet. So again, more capable on the 9000, but I do have quality of service on all 3 platforms. The most capable, down to the volume level, is on the 9000. And I support data migration. Essentially, all of these platforms can behave as a Linux initiator, a Linux host to legacy storage and migrate data from that legacy storage to itself. A lot of these things, especially the multi-tenancy, the data migration, quality of service, we will talk about in some of the subsequent talks, but I want to at least give a quick list of the services that are available. And then integration with VMware, we have some integration with Hyper-V, and we now have a unified driver for Cinder for XIV and 8K, so it's a single driver for Cinder in that case. So XIV and A9000 accelerate the whole family, the Accelerate family. And we'll talk a little bit more about VMware integration at the end of our talk today. So I'm hoping that this goes ahead and plays. So this is kind of showing the grid architecture, right? This is very important. Now, we first developed this animation for the XIV, so it's showing disks per se, but basically the grid architecture takes every volume, or takes the storage in the system and slices it into partitions. Now, on the XIV, the partition size is 1 megabyte. On the A9000, the partition is 16 megabytes. But the theory is the same, right? The volume is nothing but a series of pointers to partitions, and those partitions are pseudo-randomly scattered across the box. So what this allows the box to do is it focuses all of its resources on active IOs. I'm using all of my spindles or all of my flash modules, as well as all of my compute resources. And again, when we talk about data reduction, I'll talk more about how we spread that workload across the whole grid as well. And I think one of the important things comes in this next, oops, let me go back. This next slide. So we have the previous slide here built out, and I'm bringing in new workload. Well, I need to bring in more capacity to bring that workload. So typically when I do that on a RAID-based system, I bring in a new drawer, and my new workload goes on my new drawer. With the grid architecture, it's very different. The grid architecture is data aware, meaning it knows which partitions have valid host data and which ones don't. So when I add new storage, it moves a minimum number of partitions up into that new storage and creates space across the remaining storage for more partitions. So what happens is, as I add workload and add capacity, I'm not only adding capacity, I'm adding performance as well, because in both cases, in XIV I had a module, in A9000 I had a grid element, which is 2 compute nodes and a 900. So I'm adding cache, compute, as well as storage. But the real benefit is the workload gets evenly distributed across all the resources of the grid by the grid itself. So as sysadmins or storage admins, we don't have to worry about figuring out data placement on the grid architecture. And this is one of the key differences for the grid architecture. If you're using RAID, I say if you add capacity, you add complexity. You add more things to track, right? Whether it's drive size or drive speed or RAID type, there are lots of things that you might have to add capacity. In the grid architecture, you add a predefined, what's called a module or element, and the grid takes care of the rest. So growing in a grid on the grid architecture is very, very easy, very, very simple. It's essentially adding hardware and letting the grid do what it's designed to do. So I'm going to pause there for a second. That's kind of my brief overview before I get into some more details. Are there any questions at this point in time?
Yeah, we have a point-in-time flash copy currently set up on V7000 and DS8100. So, you know, we are out of space and we wanted to bring in XIV, but it doesn't support within, you know, TPCR or the architecture, discrete target volume on a copy.
I'm not familiar with that term, but
A point-in-time
Yeah, point.
So you
yeah,
know the target gets mounted for a point-in-time backup to TSM.
Okay. So well, I would suggest we do that with a snapshot and overwrite the snapshots. But we can I can
Okay.
certainly, I think there are ways around that. We can talk about that offline.
Oh, great, thanks.
Yeah, just get a hold of me later and we'll figure out what we need to do there.
Will do. Thanks.
Anything else? All right. So moving on to now a little bit about the 900. I've got a line drawing of the 900 showing. So I've got, again, canisters in the back where I've got my connectivity to the outside world. I've got my redundant crossbar, and then on the bottom I've shown the essentially a line drawing of a micro latency module inside the flash system. And you see some of those sections there have solid lines and some are dotted. When you look at a 900 and you see a 12 terabyte version, a 29 terabyte version, or a 57 terabyte version, it's the exact same card. It's just I have more or less of those chipsets on the card populated. So that is why there are certain limitations on the smaller capacity 900 from a performance perspective, because I have much fewer internal resources on the micro latency module to talk to. So we hit some throughput restrictions that are based on the micro latency module itself. The difference between the 29 and the 57 is there, but much smaller. On the 29, I've got 2 sets of chips. On the 57, I've got 4 sets of chips. But the difference between 1 set of chips and 2 sets of chips, the difference between 12 and 29, again, can cause noticeable difference in performance, especially when you talk about high bandwidth applications. That being said, I only support that 12 terabyte box in the A9000, or the pod as I sometimes call it. That is not supported in the 9000R or the rack version. So this architecture is basically a hardware data path. I don't have any processing really going in the data path. I've got all ASICs and FPGAs in the data path. And that's important because, again, for a disk-based system, if I add a little bit of time, because of my software in the data path, I really don't care because it's hidden essentially by seek time. In the flash, your seek time is essentially the time it takes to fill a register, which is next to nothing. So having an all hardware data path becomes very important because I want to get the maximum benefit of that flash media, and the way we do that is with this hardware data path. The guys at Texas Memory System, again, this is where we acquired them after we acquired the XIV, but they have been doing this sort of thing long before there was flash, right? Their product was first called RAMSAN. They were doing this sort of a device with DRAM, again, to get blazingly fast speed. So it was very natural for them to take that architecture and modify it for use with flash. And that was why we picked them up, because of their unique approach to doing that hardware data path. I do have concurrent code load. I do have concurrent maintenance. The one thing I don't have yet in the 900 is I don't have the ability to concurrently add capacity. I can replace a failed micro-latency module, but I cannot concurrently add capacity. That is coming in a future release of the box. Not planned for this year, but we're hoping to get that in the box we have next year. One of the things that we do inside the 900 that's unique is this variable stripe RAID. So again, if you look here, I've got a bunch of these chipsets, right, up to 4 on each micro latency module. And then what I do is I take those flash chips, I divide those they're already divided into planes, and I create a RAID 5 array across, a RAID 5 stripe across a plane. So I'm actually creating a RAID 5 stripe that's smaller than the chipset. And this allows us to do a lot of really cool things. 2 main things, really. It allows us to handle lots of little failures without having to fail the micro latency module. It also allows us to protect the performance envelope of the device so that as things wear out and fail over time, we do not change the performance characteristics. That's one of the key differentiators between flash and SSDs, is that with the hardware data path and managing at a very minute level, I can have a lot of failures and have things wearing out and still not have performance changes over time. The other thing it allows me to do is handle hundreds or thousands of little failures inside a micro latency module before I have to replace that micro latency module. So it, again, allows me to extend, one of the things we do to extend the useful life of the micro latency module and the flash inside of it. And then this, I think I have an animation, yeah. So this, again, is more things we do inside the flash system. Lots of different things. We have a unique error-correcting code that allows us to get better usage of the, better endurance of the flash system itself. All right, we do health binning, which allows me to place my hottest data on my healthiest cells, and heat segregation, which allows me to take data that is of the same relative heat, right, warm, cold, and hot, and place those in and group those together on cells. So all these things we do and more, but basically, again, it's a kind of a twofold thing. It's to protect the performance and to increase the endurance. And a lot of these things together, what allows us now to offer up to a 7-year warranty on the, or 7-year of support, right, on the flash module itself. So for 7 years, we're going to guarantee that the customer can't wear it out, and even if they find a way to do that, we're going to go ahead and replace it anyway. So now I'm going to move away from the 900 and start talking more about the 9000. So again, we look at the full system with the number of cores, the amount of memory that I have. There are two options for the 9000. For the grid controller, I have the default, or the regular one is an iSCSI, a fiber channel and iSCSI combined. There is an all iSCSI option. So on the combined one, I have 4 fiber channel ports and 2 iSCSI ports. On the all iSCSI one, I have 4 iSCSI ports. And I'm not aware yet that we've sold an all iSCSI version, but we do offer that for more connectivity in use for an all iSCSI environment. So I have grid controllers. Again, if you're familiar with the XIV, these are analogous to interface modules and data modules, that's just interface modules, excuse me. So that's where I have my connectivity to the outside world. Again, my fiber channel and my iSCSI go in the grid controllers. They come in groups of 2, right? 2 grid controllers plus 1 flash enclosure is a grid element. Now, one of the talks I'll be giving later, we'll talk about performance. I'll also talk about best practices. You think about looking at here, I've got up to 12 of these grid controllers with 4 fiber channel ports each. That's 48 ports. That's a lot of ports. It's too many ports and too many paths, especially in a VMware environment where you have cluster limitations based on paths to the volumes. So again, like XIV, I kind of split those fiber channel modules in half, right? I say 1 and 3 are used for host connectivity, 2 and 4 are used for migration or replication activity. So I've cut the number in half now. I've gone from 48 to 24, which is probably still too many. So again, we'll talk about some best practices for zoning and performance when we talk about the performance stuff in a later discussion. Next part is the 900, right? The flash enclosure itself. They are all joined together by an InfiniBand interconnect. This is a 56 gigabit capable switch. The grid controllers The cards in the grid controllers are 56 gig capable. The cards in the 900 are only 40 gig capable. So again, we're looking to get a faster InfiniBand interface in the 900 in an upcoming release, and that will, again, we don't typically have internal bandwidth problems with the InfiniBand because it's very high speed, very low latency. But again, once we get the newer 900, we will and then have 56 gig complete through the system instead of only going 40 gig to the 900s now. And then I've got power distribution, which is essentially an unmanaged PDU. I've got a slide later in the talk about how we do power protection. So looking at some of the building blocks, again, these are common building blocks. I've got a grid controller, which is a modified 3650 M5 server. It's a dual socket. I have two HDDs I put together in RAID 1 and use as my boot device. I also have two SSDs, which I use for vaulting, and again, we'll talk about vaulting in a little bit. Each one has two hardware compression offload engines. So the Colorado Creek card, if you're familiar with SVC, it's the same, essentially the same card that we put in the SVC to do the hardware compression offload, and then two batteries. So this is very similar to a DH8 or an SV1 node, just from an overall capability perspective and features and functions. And then you look at the flash enclosure again, 12, 29, or 57. In the A9000, they are always fully populated. Now, if I'm going to sell a 900 as an application accelerator, I can sell that in smaller configs, but not inside the 9000. They're always fully populated inside the 9000. Again, it is a highly available, fully redundant solution in and of itself with, again, internal battery protection as well. Now, I look at some of the things that are unique to the 9000R. All right, so for the 9000, I don't have a switch. And I'll show you when I show you the back of the module. I'll show you how we deal with that. But it is a 56 gig switch. Again, it has a redundant BBU solution as well. I've got a 20 kilowatt PDU for power distribution. One thing to note here is there is a 3-phase and a 60 amp 3-phase and a 60 amp single-phase solution for the 9000. The single-phase solution requires 4 power cords. The 3-phase solution only requires 2 power cords. Now, working with development to try to get that modified because a minimum config can run off of 2 single-phase circuits. But right now that is not supported. Basically, you have to have all 4, even though 2 of them are essentially sitting unused until you add more modules in. But that's a key difference. The XIV required 2 of either single or 3-phase. The 9000R requires 4 single-phase, but only 2 3-phase. And then there is also currently a maintenance module, which is a 1U server. There is a modem available for that if the customer wants to do a dial-up line by RPQ only. I have heard discussions that the maintenance module is going to go away. Not a big deal. It is not used by the customer. It can be turned off, yanked out, changed, and without ever changing or affecting the customer's data. It is used by our service folks as yet another additional path into the box and a place sometimes to stage files and code if they need it. So the decision is made that it's not used enough that they are thinking about just replacing that with a 1U filler plate on the 9000 and not shipping the maintenance module. Again, no change from a customer perspective. Nothing they do is affected or uses the maintenance module. Now, I'll go into a little more detail on the differences between the 9000 and the 9000R. So in the 9000, I've got dual 8-core. It currently ships at 192 gig of DDR4. In late May, we're going to make a change to this. We're going to bump that from 192 to 256. And looking forward to the follow-on solution, we're going to make the grid controllers in the pod and the rack be exactly the same. And there are a number of reasons for that. Obviously, data reduction relies heavily on memory, so I do get slightly better performance out of my rack than my pod because, as you'll see in a few seconds, I have more cores and more memory in my rack. And we made the decision to go ahead and deal with a slightly more expensive pod solution because what that does is it gives us better scalability when we talk about, oh, well, your pod is doing this, your rack is going to do this. So we've made the decision to go ahead and do that for those purposes. So again, the 2 HDDs, the 2 SSDs, for the 9000, I have 2 InfiniBand cards. In the 9000R, I only have 1, and that's because, again, in the 9000R, I have a switch, and everybody goes to the switch. In the 9000, it's an 8U solution. So I run extra cables to connect everybody to everybody else. So I need extra ports in the grid controller so each grid controller can talk to the flash system and the other 2 grid controllers in the 9000. Again, the compression accelerators and then the host adapters. Again, if the standard config would be 3, the 2 fiber channel and 1 iSCSI, or the iSCSI only would be 2 dual ported 10 gig iSCSI adapters or GigE adapters. And then looking at the 9000R, so I go to from 8-core to 10-core, so again, more processing power. I go up to 384 gig of memory, so more memory. Pretty much everything stays the same except for the 1 InfiniBand card. Again, I have a path from this card to each of the switches, so if I lose anything in the InfiniBand fabric except for this particular card, I still have connectivity from this grid controller to everything else because it goes one path goes to one switch, one path goes to the other switch. And then the same compression accelerator as well as host adapter. And here's kind of a picture of the back. So at the top, I've got my 9000R with the 1 InfiniBand adapter up here. 9000 again has the 2 InfiniBand adapters in blue. The top one of the 9000R is what I call the standard. It's got the 2 fiber channel and the 1 10 gig. The bottom one there shows the iSCSI only. And I show this because it's kind of important. Unlike the XIV, there's no patch panel on an A9000. There's a small one that just allows for Ethernet connectivity for management. But as far as data connectivity, you're plugging directly into the module. So this becomes very important because if you look closely, you can tell the difference between the fiber channel and the 10 gig card, but they're right next to each other, and it's the same SFP, right, or the same form factor. So it'd be very easy to inadvertently plug a fiber channel cable into a 10 gig card, and not going to hurt anything, but it ain't going to work either. So I've asked for some labeling or some color coding on the back to make that a little bit easier to do, but I'll show you the picture so that, again, you know that where the fiber channel are as relationship to the iSCSI. And again, same thing, same sort of setup for the 9000. Both of these are set up by SSR. So even if the customer buys a 9000, it shows up on their site, you know, a bunch of boxes, a bunch of pieces, but an SSR comes and puts it together. So the SSR takes care of plugging in the InfiniBand cables and all of the other redundant management paths that we have on the box. But in each case, the customer is technically responsible for hooking up the data connections. So again, kind of a picture of the grid architecture that we've, again, inherited from the Accelerate code family. So again, I take every volume and make it and cut it into partitions. Again, 16 megabyte partitions. But then as I build out, right, I get a nice spread across all of my available flash enclosures. I think Jim is going to maximize. This is a maximum size that Jim is going to allow for now at a 3 grid element. It does scale up to 4, 5, and 6. And I'll work on convincing Jim that it's okay to make things bigger. But there's a full lot. Again, the grid architecture, as I MES or I add these modules in, the grid architecture is going to take care of moving that data and ensuring the balance of use of both my capacity as well as the compute and memory resources in the grid. So one of the things that we were able to do with the 9000, because I have separated out my compute platform from my storage platform, again in the XIV, a module has everything. It has drives, it has cache, it has processors. Here in the 9000, I have a grid element, and a grid element has 2 grid controllers and a flash enclosure. So I've separated my compute from my storage. So what we've done is we've done triple cache redundancy instead of dual cache redundancy. And then a write comes in, it goes to an interface node that sends it to a cache node. And again, that cache node may or may not be on the same grid controller. That cache node then has the responsibility to send a copy to 2 additional cache nodes. And then at some point in time, the data is destaged. And we'll talk about data reduction next. And the diagram becomes a little more complicated, but that's kind of the simple look. Again, I can now handle up to 2 simultaneous grid controller failures and still maintain a valid copy of the cache and the data on the box. So then I'm going to add in data reduction. So I've added a data reduction node into, again, each grid controller. So it starts out exactly the same, right? It comes in an interface node, it goes to a cache node, it's triplicated or duplicated depending on your perspective there to additional cache nodes. And then now I have the concept of an upper cache and a lower cache. It's the same physical cache, but it is logically separated into an upper and a lower. So these non-reduced data goes into the upper cache. From the cache node, then, it is sent to a data reduction node. And again, that data reduction node may or may not be in the same grid controller as the cache node. And this part here is kind of important. Because we've separated the compute from the storage, we now have more flexibility on where we do work. Again, if you're familiar with XIV and XIV, I had to have the cache node and the data reduction node in the same module because they were talking to a drive in that module. Now, because I've separated the storage out from the compute, I now have the ability to use my grid to move my data reduction work wherever I want to in the grid. One thing I forgot to mention in the previous chart, I'll go back, is at this point in time when I have 3 copies of the data in cache, that's when I acknowledge the host. So when we come here, right, I've acknowledged the host at this point in time, and then I do data reduction after the host has been acknowledged. So it goes to the data reduction node. It is reduced. We'll talk about that in a little more detail in the next couple slides. Then it goes back to cache. Now this is essentially now my lower cache, where it is also sent to 2 additional modules. So now I have upper cache and lower cache. Again, upper cache is non-reduced data. Lower cache is reduced data. I can fulfill a read request from either upper cache or lower cache. Now, obviously, I'll always try to do it from upper cache if I have it in upper cache because that's going to be faster. I don't have to rehydrate the data to send the data. But if I have it only in lower cache, which is possible, then I can also service that request from lower cache. And then at some point in time, it is destaged from lower cache to A900. Now this points out another difference between XIV and the 9000. The XIV, I used my grid architecture for data placement as well as data protection, meaning I had a secondary partition and a primary partition in the XIV, and I managed to keep those copies the same, and that's how I use data protection. Think of XIV as a really big RAID 10, but at that 1 megabyte partition level, not at a drive level. Because of the initial cost of flash and the data protection qualities of the 900, I only use the grid architecture in the A9000 for data placement, not data protection. I use the 900 and its what we call dual RAID or multidimensional RAID for data protection. So the data is protected by a separate 900, but the grid architecture then assures that I've got data placed across every 900 in the system, and then it gives me that ability to do MES and to grow the system very, very easily because the grid architecture handles the data placement, the data movement that comes with adding additional capacity. So now talking about the data reduction, right? So we have two forms of dedupe. We have pattern removal and dedupe. Also have compression, and then I do have space-efficient snapshots that are redirect on write. So we'll go dive into data reduction a little bit more. So again, I do an 8K pattern detection for deduplication. So if a 64K write comes in, I'm going to split it into 8K pieces. I'm going to then look at each of those 8K pieces. If I find a pattern, I'm going to remove it. Basically, so pattern recognition is the most efficient form of data reduction because essentially I don't store any data anywhere except for it says pattern 2 or pattern 10. And currently we have about 260 patterns that we recognize as well-known data patterns. Looking at, again, kind of a roadmap discussion, one of the things we've talked about that I don't have a commit yet for is so those 260 patterns are the same for every A9000 in the world. But what we've talked about is putting a little bit of extra smarts in each A9000 and letting it learn a few patterns that are unique to itself. Again, not even a committed item, but something that we've talked about with development. But again, because pattern recognition is the fastest, most efficient form of data reduction, we are looking at ways to enhance that. Again, on the flip side, though, without making it taking so long that it undoes the benefit of having flash on the back end in the first place. So I'm done with pattern removal. I'm going to go ahead and look for true dedupe. I'm going to, again, if I find that, I'm going to remove those and basically create references to where I've already written the data, and then everything else just gets compressed. And then I will store the fingerprint for those 3 compressed partitions, so the next time that data is written, if it's written, I can then go ahead and count that and use that for dedupe. So we have 3 and actually even 4 levels of discussion here. Now we have raw capacity, and this becomes, and very rarely do I have discussions about raw capacity with customers. First of all, because it's kind of meaningless. They're not paying for the raw capacity. They're paying for the usable capacity or the effective capacity. But it does come into account sometimes for pure comparison density purposes. And the micro-latency modules are hugely over-allocated. I think close to 60% over-allocated. So even though I say it's a 5.7 terabyte micro-latency module. It's actually roughly 60% bigger than that, and that's another one of the tools we use to handle, you know, the reliability and performance of that micro-latency module. But let's assume we're talking about using the 5.7 terabyte micro-latency module. So usable capacity is how many physical bytes can someone write to that storage. So in the case of a full-up 9000R, it'd be 6 times 57 or 340 terabytes of usable capacity. Effective capacity is how much can we actually squeeze in there with data reduction. So that becomes a factor of your data reduction ratio, and that is a factor of the data itself. Now, we can make some guidelines and guesses based on types of data, and typically we see, you know, the dedupe works very well, again, for VDI is well known, but it also works well if a customer is running multiple copies of the same database in the same box. That actually is a fairly good benefit for dedupe. But for the most part, dedupe is you get benefit from dedupe for a much smaller percentage of the workloads than you do from compression. But again, total data reduction ratio gives you effective capacity. So I take that, again, there's a mythical 5.26 marketing number. Take that 342 times 5.26, you get 1.8 terabytes, or 1,800 terabytes, 1.8 petabytes. So with the most recent version of the GUI, though, we've stopped talking about effective capacity, and we use projected system capacity in the GUI itself. Now, I believe the marketing material still talks about effective capacity, so there's a little bit of a disconnect there between what the GUI says and what the marketing material says, and that's kind of why I'm touching on it. So again, the effective capacity is a function of the data reduction ratio, which is very data dependent. And actually, let me see if I can do this. Are you now seeing the GUI?
Yes.
All right, cool. So this is the new GUI, and you can see on this particular place, I've got a 900, an XIV, and an Accelerate all running, all managed by the same GUI. I'm going to go to the 9000 because that's the only one where we do the. And here you see the projected system capacity. And right here, I can click on that little doodad, and I come to this point here. Let me scroll down just a little bit. And I have two options here. The use is, again, the default is the use is a combination with the dynamic algorithm. The others use is a fixed size. This is now settable by the customer or by us, depending on who's managing the box. Default is 5.0. I can change that. All right, I can change that. I'm going to change it down a little bit. And then what we want to do is look at the projected system capacity here. It's saying it's 283. So what that is how much data has been written and the data reduction rate of the written data plus how much data has yet to be written times this projected number. So I'm going to bump this down to 4.5 and hit apply. If we go back to the dashboard, oops, let's go back to this one. You see that this number dropped a little bit. Now I shouldn't have, because they're actually getting on this box. We're actually getting 5.1 to 1. But that's why I show you this. If the customer's workload is such that we're not, or data is we're not getting close to 5.5 to 1, you may want to go in there and change that, because that will make the projected system capacity align better with what the customer is actually seeing based on their data. Now, I do have a customer that's got their box about 70% full and only seeing 3 to 1. So for them, I strongly suggested they go in and change that number from 5 to 3, because again, it changes the projected system capacity, but it brings it more in line with the characteristics of their data. Now I'm going to go back here, and again, give you kind of a preview. In the 5.2 release of the HSM, which is coming in the May timeframe, I'm going to have a third option. So option now is the combination, or just use this rate blindly, which I don't suggest at all. The next option is going to be use the actual data reduction rate to do projected system capacity, which will say basically, okay, this box we're getting 5.1 to 1, I'm going to use that. But what it does is it keeps the customer from having to go back and monitor the difference between what they're getting and what they've set. The downside to that is if they are changing workloads and adding a lot of different workloads, that number is going to fluctuate a lot until things kind of settle down a little bit. I've asked for that option. I prefer that option because I think it's clearer and easier to explain to the customer why it's fluctuating because their workload is changing, as opposed to explaining them why they're not getting that effective capacity, projected capacity because their workload has changed. But again, that's as you're working with your customers, do what's best for them. But I wanted to show you that so you're aware of that option and that change that's coming in 5.2. So let me move that off to the side again. So the other thing that we don't talk about typically with customers is what I call virtual capacity, and that is the A9000's ability to manage, essentially, you can think of it as soft capacity. It's really not, but you can kind of think of that. There are some physical limitations in the box as to how much data reduction I can actually take advantage of because of table space and other restrictions in the code and the architecture. It is a variable number because it changes based on resources, and as you might know, right, with the pod, I have one set of resources, but with a rack, I have 4 different sets, right? I have actually 5, right? I have a 2-grid element set, a 3, a 4, a 5, and a 6. So each of those is a different resource set. So each of those has a different virtual capacity. However, you will not get into any difficulty at all unless you're running a full-up box, a 6-grid element box, and getting better than 10 to 1 data reduction. At that point in time, we may see some limits in the data reduction based on the internal capabilities of the box, but I've not seen a customer with a full-up box, and I sell very few full-up boxes, but haven't seen any customer come anywhere close to that limit, so I think we're okay. But if you run into a situation where you've got a very, very large config and very, very good data reduction, we may run into that, and we may need to do some work there to help mitigate the effect of that. Again, just to let you guys know. Basic dedupe mechanism. So I'm going to split the user right in its constant size chunks. I'm going to calculate a SHA-1 hash for each 8K. So another thing there, if I get very, very small I/O, if for whatever reason I'm getting 2K or 4K I/O, there is a potential there that I will not be able to take advantage of dedupe for very small block writes. Now, I mitigate that by I will coalesce those in cache and then do the data reduction after I've coalesced. So if I get a bunch of 4K writes that are in a row or they line up, I still may be able to do dedupe if those 2 4K writes come in close enough in time to each other and they make an 8K piece. So I can do coalescing in cache to take advantage of my dedupe. Not typically an issue. I see very few workloads, and again, if somebody does have one, please, when I stop for questions, let me know. But I see very, very few workloads that are smaller block sizes. I'm seeing more workloads 8, 16. I think the 4K workload is a thing of the past for the most part. That's something we can discuss when we open the lineup for questions in just a few more slides. Again, the fingerprints are stored in a repository. Future writes then query that repository for existing fingerprints. And then if I find it, I reference the existing chunk, and I don't have to write the data. Just say, hey, this data is the same as that data, and if I need that data, I reference where I wrote it the first time, not where I wrote it the second time, or the third time, or the fourth time. Pattern detection again happens first. I store them using a pattern ID. So again, I have about 250 patterns. So if I find one, all zeros, all ones, alternating zeros and ones. If I find a pattern of those, I just say, hey, this is pattern 3, and I just store pattern 3 where I would normally store data. I just put it in metadata. And then when I go to read that data, I just generate pattern 3 in memory. I don't actually reference any storage. That's why pattern detection is the most efficient. It's faster, takes up less space, takes up less computing resources. So that's why we are looking at ways to make pattern recognition, pattern detection faster and more pervasive. So somebody went off mute. I'm assuming you've got a question. No? All right, we'll move on. So yes, one, and then after dedupe and pattern recognition, then I do compress. Again, it is based on the real-time compression code. It has been, I'll call, heavily modified because part of the problem we were having. I'll move on. Okay, so again, it's based on RTC. It was when we first started. It was modified. It has since been heavily modified. One of the problems that we found with RTC and how we implemented the A9000 is we were more dependent on we were pulling too much out of essentially out of the partition, and we were pulling a full partition at first and rehydrating a full partition. That's 16 megabytes for any read request. And we found that was taking too much time and affecting overall performance. So now what we do is we do what we call partial extraction, where when I get a request, I know where that data resides. I'll go and I'll grab a much smaller piece out of that partition, hydrate that, and then respond to the read request. So we've done a lot of changes to the RTC code, and that helps in another way, because RTC is notoriously bad with synthetic data, because there is no time, there's no temporal locality in synthetic data. And RTC does rely fairly heavily on that temporal locality to provide benefit. So while we were getting really good, and in many cases much better performance than the competition with a real workload, we were getting significantly worse performance than the competition with a synthetic workload. So the partial extraction actually helps mitigate that to a large extent, because now I'm only extracting that little piece that I need. I'm not extracting the whole 16 megabyte and expecting that I'm going to get good read cache hits off the rest of it because of temporal locality. So again, same sort of concept as RTC, right? I've got variable in, fixed out, so I can do data manipulation on compressed data fairly easily. But again, we've modified it even more for the 9000. And as I showed in that earlier chart, the data reduction node resides in every grid controller, so that the grid can assign workload to a data reduction node regardless of where in the grid it resides. And again, that gives the grid some flexibility as to where it assigns workload, and again, taking advantage of all of the resources that are in the grid. So I can have data reduction going on in any grid controller for data that resides in any flash enclosure. It's just going to go into cache and be referenced in cache and then destage from the cache node, obviously not from the data reduction node. So there are some challenges that dedupe creates, and we're going to fix some of these. Some of them I don't think we can fix, or at least we haven't found a way to fix them yet. I don't have reporting on per volume usage statistics yet. I'm supposed to get that at the end of the year. We had it. We found that in a few cases it was grossly incorrect, so we removed it until we can get it right in every condition. So if the customer is using an older version of the GUI, like the 5.0 version, they may see volume stats, and those are typically correct, but there are cases where they may not be. So again, it was removed and hopefully brought back in with, I think, 5.3, which is, again, scheduled for the end of the year. I have to estimate my free space when I delete a volume because that volume may actually hold a reference partition, meaning everybody else in the box references that piece of data. So even though I delete the volume, I cannot delete that data because it is the reference partition. The other problem it creates or challenge it creates is it's very easy to do a sample and get a fairly good estimate of compression ratio. It is not easy to do that with deduplication. I have to essentially look at all of the data and look at how many fingerprints match across different volumes before I can say, you know what, you're going to get an overall data reduction of this. So my data reduction tool, while I have one, takes a lot longer, a lot more time to run because it has to look at all the data. It cannot do a sampling of the data to give a data reduction estimate. And kind of looking forward again, kind of a roadmap item, one of the things we're talking about is the ability for a box to talk to other boxes and say, you know what, the data that I have in this volume, we'd get a better overall data reduction ratio if we moved it to this machine. Obviously, I've got some tools already in there. I can do that from a performance perspective. What we want to do is surface that out excuse me, to the customer as a, hey, you know, you would get better performance and or better data reduction if you moved this volume from this box to this box. Now, with hyperscale mobility, the ability to move that volume seamlessly from one box to the other, it's even potential that we could say, you know what, and if you want me to move it, I'll move it for you. And then beyond that, I think the next step, and where I really want to get the development team to is, you know, you tell the box that Sunday night from 8 p.m. until Monday morning at 4 a.m., you can go ahead and move volumes. And I show up Monday morning, and I get a report that says, I moved these 14 volumes from here to here and here to here, and here are your projected performance and or capacity benefits from me doing that move. Again, that's a roadmap item, but that's something we're looking at, and that, to me, that is the kind of the end all for my hyperscale mobility / management, my hyperscale story to get true volume mobility that the box manages that the humans don't have to manage. Back to the charts, the data reduction estimation tool is available on Fix Central, so it can be downloaded even by the customer and run by the customer. I can run it in batch mode. I do have the ability then, once I run it across a bunch of different volumes, to run it again and look and get a data reduction estimate across what's going to be on a box as opposed to what's only in a volume. It is only a CLI, and it does require root access, and I know that does give some customers issues, which is why I put it there so you're aware of that. Power protection. So again, I mentioned earlier that every component has a redundant DBU. Well, every component that needs it has a redundant DBU. Again, a difference from the XIV to the A9000. The XIV, because it has three pretty massive UPSs in the bottom of the box. I have a 30-second grace period in an XIV. So if power goes away and then comes back inside 30 seconds, all I get is a warning or an error saying, you know, power went away, and then power comes back. For the 9000, there is no grace period. Power goes away, you get a message saying, power's gone, I'm shutting down, goodbye. And then it does a fire hose dump or destages from what's in cache to the SSDs and then shuts down. Now, in that case, if power comes back, it will come back up. It will boot itself back up. And those SSDs, again, there's 2 SSDs in each grid controller, and they're used for 2 different types of vaulting. One is what I call a live vault, which is every, and I have this mental block. I can't remember if it's every 5 minutes, every 10 minutes, but every so often, and it's fairly often, I go out and I destage metadata to my SSDs. So in case I have some sort of catastrophic metadata failure, I can go back to a copy that's, you know, at most 10 minutes old to start to rebuild from there. Those SSDs are also used to vault my write cache when power goes away. So I'll do essentially destage from the cache to the SSDs, and then once power comes up, I restage from those SSDs back into cache. So here's a picture of a 9000, again, 8U, what I call a fixed configuration. Once you get, if you fill up a 9000, you got to go buy a new one. And then looking at the 9000R, again, it's my rack, my scalable system. So again, same technology, same software. I don't have a different software tree for the pod versus the rack, but I do have scalability in the rack that I don't have it in the pod. And then looking at some numbers, again, the 9000, the 8U modular offering, based on the 900 that's in it, right, whether it be 12, 29, or 57, and again, assuming the 5.26 to 1, here the size is the effective, or now I guess they're calling it the projected system capacity, right, that we should get if we have that data reduction. Now again, if you get more, and for a pod, I think that's probable, not probable, but it's possible, because it's very possible I could buy a small pod for a VDI environment and use that whole pod and get very, very good data reduction ratio on the pod, right? For VDI and I don't have a lot of swing between my instances, I can see some very, very good data reduction ratios because dedupe is very effective in that environment. So I think it's more likely in a pod to see very high data reduction ratios than it is in a rack, just because typically VDI environments are small when it comes to overall storage capacity required, and therefore the compression and the non-duplicated characteristics of the other data override the benefits you get from the VDI on a small part. And then, so again, fixed capacity, you can't change it. The next one is the rack, and I start at 2 grid elements. And again, I offer both a 29 terabyte and 57 terabyte. So what you see here in the chart are again, the top line is the usable, the bottom line is the effective. Now, again, I don't think you guys do a lot of MESs to the boxes that you guys get, but just to let you know, if you start with 29, you've got to continue to MES 29. I can't mix my flash system, just like I can't mix drive sizes in an XIV. I can't mix flash module sizes inside an A9000. So if I start with 29, I grow all the way out to 29. If I start with 57, I grow all the way out to the 1.8 petabytes. But again, I think Jim is going with the spot he wants to start is the second config, which is the 3 grid controllers, and I believe he also specified the larger 900. And that's what I have on architecture. How am I doing for time? Actually, I'm a little bit ahead of schedule. That's okay. Let's go ahead and open it up, if you would, Karen, for some questions and answers, and we'll shut them back down for the last part.
Absolutely. So if you do have a question, please just do a *1.
Yeah, I have a couple questions.
Okay.
Go ahead.
I'm assuming you can have data reduced volumes and non-data reduced volumes in the same system.
No, you cannot. Data reduction is always on in the 9000.
Okay. Okay, I guess for question number 2. From a management perspective, when you have physically spinning storage media, and you get above that 80% threshold, you start seeing significant performance degradation. Does that go away? I mean, we're all flash-based?
Well, I would argue that it goes away with the grid architecture in general. I've got customers that are running their XIVs well over 80% and still getting very, very good performance. So
okay, so it really boils down to managing your environment, not so much from a performance perspective, but a risk perspective of filling any particular pool physically.
Pools have no performance impact because, again, even though I'm creating a pool, I am still every volume is going to, and the XIV is going to touch every spindle, and then the A9000 it's going to touch every what we'll call micro latency module. So every volume is going to be spread across all the storage resources of the grid, regardless of whether I create one pool or 10 pools or 200 pools.
Right. My question was a little bit different, but with like a thin provisioning situation, where you need to manage and plan for, what if somebody has a sudden data growth that you're not expecting, and you end up filling up the system basically before,
right.
When you're over provisioned.
Yep. Yes. So
from a management perspective, the performance issue goes out the window, and you're really managing from a risk management from that perspective.
Yeah, I'd modify your statement a little bit, right? I typically manage my performance at a box level now, as opposed to a more granular level, a RAID array or extent pool or whatever. So yes, I manage performance at a higher level, but my biggest concern becomes obviously managing capacity and making sure I don't run out of hard space. Now, again, on the A9000, it really isn't surfaced like as hard space as such, but yeah, that's exactly the concept that you're worried about.
Okay, fair enough. That's all I had. Thanks.
This is Eric Gibson. Two questions. The A9000, you say that it does thin provisioning in the background automatically. You don't have to worry about that, setting that up or anything, right?
Correct. You basically just create a pool. And again, so we got to, and I just had a customer that had this problem. They had a problem. They were creating volumes that were essentially too small. So that's kind of the thing, right? When you guys, if you've not dealt with data reduction, essentially the storage is lying to the host, right? Mm-hmm. From a host perspective, I create a 1 terabyte volume. I write from LBA1 to LBA whatever it is, and the host thinks that volume is full. Now that space may only be 1/5 used or 1/3 used, but the host doesn't know that. So the thing is, we've got to create larger volumes so the host can write all of its data, and we can still take advantage of all the hard space. So that's where the complexity comes in. Jim mentioned SVC earlier. That really magnifies the problem, because now I got to create larger volumes to SVC. The nice thing is with SVC, I've got some very, very cool tools with migrating data, but it becomes a thing of I got to make my pool large enough to create volumes that are large enough that I can actually write enough data to actually fill the hard capacity. So and that's why having that projected system capacity and that actual data reduction rate visible is so handy, because that allows you then to manage kind of how badly am I lying to the host, so I can take full advantage of the hard capacity I have, and in the case of A9000, the hard capacity I have kind of behind the curtain.
Okay. Second question. Okay, we have XIVs behind SVC. Now, the A9000, is that a recommended practice to put that behind the SVC, or is that no?
It works. So it's a question of, and what I said for Gen 2, actually, I'll go back a little bit. For Gen 2, putting it behind the SVC, we could see performance benefit. And it's really weird to me to say I'm going to put more in the data path and it's going to go faster. It's very counterintuitive, but for SVC, it actually does work in some cases. For the Gen 3, I'd say it was performance neutral, right? You're not going to get a lot better performance by putting SVC in front. because of the changes we made to the Gen 3. From an A9000 perspective, it's kind of a different question. It's not performance neutral. Now, there is going to be a potential for a measurable difference in performance, native versus behind SVC. Now, again, we're talking microseconds, but when I can get, 200, 300, 400 microsecond response time for certain workloads out of the 9000, adding 60 to 80 microseconds becomes significant. So it's a question of what's more important. Does the customer absolutely need blazingly fast performance? Well, if that's the case and they wanted to use SVC, I might suggest a 900 as opposed to a 9000. But if they want the if they need deduplication and they want the operational efficiency of the SVC, because let's face it, SVC does data movement better than anything out there, right? And it makes it very, very seamless to the customer where the data lives. If they need that, then yes, put the 9000 behind the SVC. But again, because the data reduction is always on in the 9000, you've got to make sure that they can the customer can handle the operation, the difference in operations. I'm going to do compression on the SVC for some of this stuff. I'm going to not do data reduction on the SVC for stuff that's on the A9000.
You would not do compression when you put the A9000 behind the SVC. You would turn off.
I certainly would not, because all that's going to do is send compressed data to the A9000 to be compressed, because I cannot turn it off at the A9000, but I can turn it off at the SVC.
So you would turn it off at the SVC? Is that the question?
Absolutely.
Okay. Thank you.
Hi, Steve. Ramesh here. When you explain this hyperscale manager, can we discover or add the existing systems, XIV or systems from the production?
I'm not sure I understand the question. I'm sorry.
You explained that the user interface can be used for XIV, Spectrum Accelerate, and A9000R, all three of them. Can we add the existing ones already in production?
Absolutely, yeah. In fact, it's real simple. You come in here, go to the manager server view, go to manager configuration. Chris has this one set to advanced mode. So you would come in here and basically just do an add. You just add it by IP or by fully qualified domain name.
Okay. And when we migrate from a non-thin provisioned or a thick volume to A9000R, thin provisioned volume, how does it handle zero space reclamation?
It handles it by, for the most part, it will handle it by pattern recognition, because it'll see an 8K 0 come in, and it will mark that as I know that pattern. And they'll just do it by essentially through dedupe. But more technically through pattern recognition.
Okay.
Yeah, so again, if you're familiar with XIV and the background scrub, and even if I write zeros in XIV, I'll catch it in the background scrub. I really don't have a background scrub running on a 9000. There's no need to. I don't have a primary and a secondary partition to keep in sync, so I'm not running a background scrub. But I will catch that data as it comes in through dedupe, through pattern recognition and or dedupe. And if I don't, then that data will get compressed to be ready for the next one view. But zeros will certainly be caught by pattern recognition.
Thank you, Steve.
You're welcome. Any other questions?
Is the 9000 going to be limited to 6 grids?
Yes, that is the decision. We made the decision a long time ago with XIV to not expand it beyond a single box, and we kept that single frame mentality when we went to the 9000.
is there any roadmap that sees those grids possibly being split to remote sites, so 3 inside A and B, like SVC stretch cluster?
No, but I do have HyperSwap coming in 12.1 in May of this year, so I'll be able to do an active solution. So it'll be more like, again, more like HyperSwap in SVC, but I can have active solution across 2 different A9000s, and those could be 2 pods, could be 2 racks, it could be a rack and a pod. It doesn't matter. That the HyperSwap is going to be, you know, any to any. But I do have HyperSwap coming with my next major release.
Okay, thank you.
Hi, Stephen. This is Rodrigo. I have a question. Have you tried, or is it possible to migrate volumes between Spectrum Accelerate and A9000 at the moment?
So I do not support hyperscale mobility between the 2 systems yet. That is an ask. And again, I don't have a commitment yet, but I do have a stretch goal of getting hyperscale mobility between A9000 and XIV with the 12.2 code, which is the end of this year. So it's possible I could have hyperscale mobility between XIV and A9 at the end of the year. I do not expect to get it between Accelerate until I do the next major update to Accelerate, essentially move it from the 11.x code stream to the 12.x code stream, and that won't happen until sometime in 18.
But it's still possible to replicate, right?
Again, I don't yet have replicate. That's just between you and me. That's my biggest gripe with bringing the 9000 out the way we did and when we did. I don't have any, at this point in time, I have no family interop except for Hyperscale Manager between the systems. Now, again, I have a commitment to have async replication between XIV and A9 in 12.2. That is one of the anchor items that is committed. To have that in 12.2 the end of the year. So again, that's async replication. When you think about it, synchronous replication between an XIV and an A9 doesn't make any sense, because with synchronous, I'm waiting on the response time of the subordinate array, and so not only do I have propagation delay, I also have the delay for the ACK from that box. So if I do synchronous replication between an A9 and anything but an A9, I'm going to drastically slow down the A9 while it's waiting for its subordinate array to respond. So I'm only going to support async, and that will be to XIV. I'm guessing, and I haven't actually asked them, but I'm guessing that async to Accelerate will work, but we will probably not have support, but we could probably get an RPQ if there's a business case for that.
All right. That was my main concern about SA, receiving replication from A9000 or either the XIV.
Well, I do have replication between SA and XIV now. That's there.
Yeah, we are using already. Yeah.
Yeah, but I don't yet have anything to the A9, and it chaps my hide a little bit that we haven't been able to get that family interoperability out sooner than we have been.
And my last question is about encryption. So for these guys, I can use SQLM, put it at encryption,
yes,
no
absolutely.
set drives required, and etc. Right?
So essentially, the micro latency module is performing the same function as a self-encrypting drive. And that capability is already there, because I can encrypt a 900, but I do internal key management, right? I use a stupid little USB stick to provide the key. So I'm taking that. I don't support that, but I do support key management. And I have one customer. I'd have to go back and look. I have a customer that is we've got RPQs on XIV for Key Secure, Talus, and there's one other. So I got 2 or 3 different key managers other than SKLM that are available via RPQ for the XIV, and those same customers have asked for that support. I believe I have RPQ support for the A9000 for SafeNet, the Key Secure. I guess it's now Gemalto is the company name, but the Key Secure product line. And I believe there is a customer that has requested it for the Thales key manager. So essentially, we can probably get an RPQ for anything that is KMIP compliant.
All right, thank you.
Any other questions?
Yeah, this is Keith. Regarding the deduplication, is it only in effect when you first move the data there, or can you basically like re-dedupe, or does it constantly checking for patterns to see if it can continually reduce data?
It is at the time of write only. So once it goes through the data reduction node and is destaged, it is not further reduced.
Okay, and can you then take a volume that came in and then basically recompress or re-dedupe it to see if you can get additional savings? So like basically creating like a volume copy in essence?
Right. Yeah, I'm just trying to think of an instance where that would, because it's box wide, if the data is already on the box, I'm going to dedupe it anyway. So there's no. So you're saying if data changes in a volume over time and it changes 2K at a time or something? Yeah, I can see a case where if I'm making minor changes to a volume, I might be able to get better dedupe over time. But no, I'm not aware of any method that would kind of rehydrate and then dehydrate again. Even the volume copy probably is not going to do that because a volume copy is the mechanism on the volume copy might pick that up. I'll tell you what, I will take that as a to-do to go get a better answer for that. I'm not sure if a volume copy would force that or not. I don't think it will, but I will find out.
Yeah, as an example, I know on the SBC side, like the zero space reclaim, that kicks in if you basically rethin a volume, for instance,
right.
Meaning you create another volume copy and then you break off the source. The zero space reclaim also comes into play at that point in time.
Right.
Not that it's necessarily a lot, but if you literally have a whole bunch of data that, okay, now we just scrubbed all this data, you could, in essence, rethin it versus having to give new LUNs, I guess.
Yep. No, I understand the question. I hadn't thought about it. You know, as a volume change over, like say I do a 2K right here, 2K right there, and all of a sudden now that 8K would dedupe where before it didn't. I have to find out if a volume copy would force it to go through that, whether it goes through the whole rehydration and dehydration and dedupe process again, or whether it's more of a, oh, I'm just going to copy this partition from here to there because I know it's already the same. I don't have to rehydrate. I'll find out.
Okay.
Hey, Steve, on that same vein, the VMware APIs to reduce, to compress thin volumes or reclaim the space.
The unmap?
Does it recognize those APIs?
Yeah, it's in fact you nice lead into my next session, but yeah, I have support for all 4 of the VAI primitives, unmap included.
All right, thank you.
And I think we'll have time again. So again, the last section is VMware integration. We've been a partner with VMware for a long time. The XIB team actually initiated what we call a quarterly technical review with them. We have pulled in, SBC now participates as well as AK now participates in those reviews. So basically it's where we get together and talk at a non-disclosure level about kind of where they're going, and what they're going to do with storage and where we're going, what we need to do with virtualization. And we call them a quarterly, but I think we only manage to get 3 a year. So, but we do those, and actually the next one is scheduled to be end of April over at the VMware facility in Palo Alto. We have actually hosted those QTRs with the development team in Tel Aviv before, which is kind of fun because we typically get a tour of Jerusalem as part of the work activities. So again, an overview of our integration. A lot of it is through Spectrum Control Base, which is a free piece of software that customers can download, run on a virtual machine. suggests two, right? So I have a primary and a secondary copy, but you only need one. But I don't support VVol yet on the A9000, which is another burr under my blanket. But everything else we do support. I have the SRA for XIV and A9000, so we support SRM for the device. We do support their what I call their automation chain. Their automation orchestration is through Spectrum Control Base. Their operations is through Spectrum Control Base. A plug-in into vCenter, the VASA provider is handled through Spectrum Control Base, and then we also have their web client can talk to Control Base and allow the customer to the storage admin actually assign a pool to that vCenter, and then the VMware admin has the ability then to create data stores from that pool without having to come back and ask for permission to the storage guy. And it's kind of nice. I can give them a pool and say, this is your pool. If I want to, I can even put a quality of service on that pool and say that pool is never going to get more than 40,000 IOPS or 80,000 IOPS, whatever that number is. So I can actually give them a pool and then make sure that they don't break my other production workload by putting a quality of service on it. And then also there's through Spectrum, we have data protection through the VADP in the vCenter through Spectrum Protect. But again, most of what we do for the XIV, the A9, is through Spectrum Control Base. Again, free piece of software that's available for download, runs on the virtual machine. So it's a low-cost solution. Not a lot of customers are taking advantage of this, I think, in part because it's not, I'll try to be kind and say it's not the easiest software to use, although it does do what it's advertised to do. And again, through Spectrum Control Base, I have support for not just for XIV, but for, virtualize. The entire Accelerate line, 8K even, has support through Spectrum Control Base. And then here, again, some of the capabilities. I've got the vCenter management integration. I've got the VAI integration. I've got a VASA provider. Now, currently, I only have a VASA 2 provider, which is up to 6.0, but 6.5 introduced a VASA 3 provider. That is a roadmap item. And please, now I know there's a bunch of people on the call, if you have a customer that has a VASA 3 requirement, please give me that customer name and the potential revenue there, because I'm trying to build a case to get to development and offering management to say we need the VASA provider sooner, because right now we're not scheduled to get VASA 3 until sometime in 2018, and I think that's way, way, way too late. So if you've got an opportunity that's for whatever reason the customer has said, and I believe our competition is going to catch on to this and start doing this soon, is making the VASA 3 a requirement on the RPQ. If that comes up, please let me know, and let me know how big the opportunity is so I can add that to the case to develop and say, guys, we really need this sooner. SRM integration through the SRA, again, all this stuff there's nothing here that the customer has to pay for from our side to get this. Right? Obviously, they do have to pay for SRM, but the SRA is available at no additional charge. The vRealize suite, again, that connectivity comes through Spectrum Control Base. The API for data protection comes through Spectrum Protect. And then there's, again, Spectrum Control Base is a separate piece of software from Spectrum Control. I know we have Spectrum Control, I think it's Advanced and Enterprise, and you would expect if I've got Base, Advanced, and Enterprise that Base is part of the other parts, but it isn't. So if a customer needs these integrations, they have to have again, it's not a cost to them except for the cost of managing a virtual machine, but that is not included in Spectrum Control. Even though they share the name, that's about all that they share. Just a real quick look at the VAI. Again, I got a full copy. I've got a block zeroing. I've got the unmap, and I've got the atomic test and set, or the sub LUN reservation available. SRM again. We'll make these slides available. I've got the SRA and these some of the SRM use cases. And that's all of the boring presentation that I have. What I want to do next real quick is just take a real quick look at how are you doing for time? Yeah. So here again is the Hyperscale Manager. Again, I've got a 9000, an XIV, and the Spectrum Accelerate here. I've got my dashboard. For those who are used to the XIV GUI, I've got some things across the side here that are, you know, should be pretty similar, right? Systems view, stats view, pools and volumes, hosts, that sort of thing. I also up here have a new item. I can do a new volume, a new host, a new cluster. Lots of things you can do up there too. Overall, I'm getting really bad data reduction, but that's because Accelerate doesn't do it at all. I'm not sure what's on this one XIV. If I switch over just to the 9000 view, obviously I'm getting pretty good data reduction on this particular 9000. You can also see that this changes, whereas before if I'm looking at all of them, I've got a 79% health, right? I've got capacity issues, I've got hardware issues, I've got connectivity issues. I'm guessing that 2 of them are using a default password. Oh no, we've got some connectivity issues, other connectivity issues. So again, I got a nice view of what's going on from a connectivity issue, but if I switch to one of the boxes, none of those issues apply to the flash system, right? They must apply to the XIV and or the Accelerate and or hosts that are attached only to the XIV or the Accelerate. And then the other thing I want to show you real quick is Spectrum Control Base. And again, I'm using the setup from the Tucson Executive Briefing Center and Chris Keller, who's the guy. I think he does a really good job. So you can see I've got SVC, Storewise, XIV, Flash System, a Storewise V5, another XIV and Accelerate, and even just a pure Flash System 84900s, all included in Spectrum Control. Now, I've only created a service for Accelerate. And that's basically how this works. I add the storage in, then I create a service for the storage, and then I can come over here and I can map that service to a vCenter or to an orchestration or a automation instance. And I just want to give you a quick look at that again. That's how we get integration into the vCenter, as well as if the customer is going to do vVol on the XIV, then they need Spectrum Control Base. They would create a vVol service, attach that service to one or more XIVs, and then surface that service up to the appropriate vCenter or vCenters. So that's all I have, except for we've now got about 15 minutes for final Q&A. Is there anything else I can help you guys with?
So related to the ESX environment, on the SVC side of the house, typically you've got ESX host servers that may have, let's say, 4 HBA ports. So due to path limitations with ESX and as well as for performance, you typically then create 2 host definitions for any given ESX host, and then you split LUNs between those. How would the A9000 handle that?
I would suggest, if it's at all possible, to go with larger LUNs and avoid the problem that way, as opposed to doing the dual mapping. So I can make my the problem is I know customers like to have their data stores a specific size. But if I can't go to a larger data store, a larger volume, then you could solve it the same way. But you got to be, again, kind of be careful. We'll talk about this a little bit in performance. I got to make sure that I don't have 24 paths to begin with, right? Again, for your guys' case, again, starting with a 3 grid element, that's going to be 6 controllers, 2 ports each. That's could be up to 12 paths. From a VMware environment, I would say go with 6 paths, right? 1 to each grid controller, and then so that limits the number of paths we have to start with. So I can again, depending on the size of the cluster, SVC cluster, I may have to have more paths. But for your starting point, which is a 3 grid element, I would just go with a 6 paths, 1 to each grid controller, and that gives me the ability to, again, distribute workload evenly across the A9000, but minimizes the number of paths I'm using.
Well, normally in a dual SAN fabric, right, you'd want connectivity to each of the controllers on each fabric, right?
You can, right? You would bump that to 12. But for some of what we've been doing for XIV as well as for A9 is half of the grid controllers are on one fabric and half are on another. So yes, it is a potential performance implication in the case of a fabric failure, but my experience is that complete fabric failures are pretty unusual these days.
Okay, so instead of splitting controllers across the 2 fabrics, the recommendation from an A9000 cabling-wise is you attach both fiber channel connections to the same fabric for a controller?
So what I would do is I would put port 1 on fabric A and port 3 on fabric B. But then I would use zoning then to control how many total paths I have, right? And if I'm not worried about throughput, if I've got basically just an IOP-driven workload, I would use port 1 on half of the grid controllers and port 3 on the other half of the grid controllers. So I've got again, I'm touching every grid controller, but I'm only using a minimum number of paths. Again,
gotcha.
The downside is if I have a fabric failure, I lose half of my paths. But again, my experience is those are not common events.
Right. Okay. And the A9 doesn't complain when you set a server up like that. Like I know the SVC does, but
yeah, it does not. It will complain if I lose enough paths that I'm down to a single path. But as long as I see multiple paths, even if I don't have a path to each grid controller as best practice, the A9 will be fine. It will say, hey, if you're losing paths, it'll say, hey, I'm down to 1 path, and then, oops, I'm down to no paths. I can't see that host at all. But it will not complain about, oh, not every grid controller sees that host on every path.
Okay. So yeah, so it doesn't error out with, hey, this host can't see port 1 on all the grid controllers.
Correct. It does not.
Okay, got it. All right.
If I could ask a follow-up to that question.
Go ahead.
If my host doesn't see a path to controller 1 on both fabrics, and my storage I/O is coming down to controller 1 on fabric A, and I lose that path to controller 1, it's going to have to fail over to a different controller, still on the same HVA. Is that going to take a while to time out and fail over to another controller on the storage? Or am I just looking at the longer timeout when the HBA failover occurs on the host?
Typically, multipathing is a much faster timeout than what I call the transfer, the SCSI timeout. So yes, there will be some amount of time loss, but it's milliseconds, not seconds, as a total path failure for a SCSI timeout.
Okay. Thanks.
Hi. Can you talk a little bit about Global Mirror and how it might integrate with hyperscale?
Yeah, I can, but what I'm going to do, if you don't mind, we do have a session. One of the sessions coming up is replication and migration. So
Perfect.
I will go over that in detail, but if there's no other questions, I'll use the last 10 minutes, but I want to make sure I cover any other questions because I am going to cover that later. Is that fair?
Very good. Thank you.
Okay. So global mirror doesn't, we don't call it global mirror on the A9000, we call it async replication. It is managed, I think Chris may have something set up. Let me take a look. Oh, he only has one, so he can't have anything set up yet. Thank you for bringing that up. I will have to log into the Washington System Center for that one, so I can show you replication on the boxes. But basically, it's async and it is snapshot based. So basically, I use the snapshot and then use the differences between snapshots to send the data from the primary to the secondary, and that is done through the hyperscale manager, but it does not really relate to hyperscale mobility, because if I do hyperscale mobility and move a volume, at this point in time I lose all of the snapshots and all of the replication relationships with that volume. Now, there are two separate roadmap items. One is in 12.2, which will give me hyperscale mobility with snapshots, meaning I can move a volume and move its snapshots as well. And then sometime in 18, yet to be determined which release, I'm supposed to get hyperscale mobility with mirroring, meaning I can move a volume that is in a async or synchronous relationship, and as long as the appropriate connectivity exists between the new primary and the existing secondary, I can keep mirroring in place while I'm doing a hyperscale mobility. So I try to be really careful and really kind of bombastic about this, because I use hyperscale something for everything that's cool on A9000 or XIV. Right, that's why I separate into what hyperscale manager can do and what hyperscale mobility can do, and that sort of thing. So there's your preview, and then we'll Karen is after me almost on a daily basis to give her dates to schedule the rest of the sessions, and you'll see the invite for the one on replication and migration. And they will be shorter sessions. I think the following sessions are an hour each, but I wanted to get this big the architecture out to you guys in kind of one fell swoop so that you can kind of digest it and then have it in mind as we're going through. The rest of the sessions are really more on features and functions on how the box does specific things as opposed to how the box works overall.